Welcome to day 2 of sum and difference formulas. We just finished up looking at the formulas for sum and difference of cosine, sine, and tangent. We also proved the sine and cosine sum and difference formulas. Now we're going to look at something a little different here. We're still going to use the formulas, but I'm going to give you some information, and you have to find the other trig functions so that you can use the sum and difference formulas to find sine of alpha plus beta, cosine of alpha plus beta, and tangent of alpha minus beta for this example. So I'm giving you sine of alpha is 3/5, and I'm telling you that alpha is between 0 and pi over 2. So that second piece is important because we know sine is positive in two quadrants, quadrants 1 and quadrants 2. So that second piece of information is very important. So I'm going to create this angle in quadrant 1, knowing that this is alpha. Sine of alpha is opposite, so that's 3 over the hypotenuse, which is 5. And then we can find the missing part of the triangle by using Pythagorean theorem. So that's x squared plus 3 squared equals 5 squared. And you might recognize this one as a 3, 4, 5 triangle, which is fine. 25 minus 9 is 16. So x could equal plus or minus 4. And it's important that you recognize it is plus or minus 4 when you solve, because depending on the location is going to depend on whether that is a positive or negative 4. Since it is in quadrant 1, it is a positive 4. So now we know a couple other things. Not only do we know that sine of alpha is 3/5, we also now know cosine of alpha, which we need when we use the sum and difference formula, is 4/5. And then we'll also need tangent if we do a tangent sum and difference. So there'd be tangent would be 3/4. So those are the ratio for the three trig functions. Now we're going to go over to the other side. Cosine of beta is equal to 2 squareds of 5. Beta is located in between 0 and negative pi over 2. It's greater than negative pi over 2 and less than 0. So we're going to do the same thing. We're going to create where beta is located. So it's in between 0 and negative pi over 2. So we know it's in quadrant 4. Cosine is adjacent, so that would be positive 2 over the hypotenuse, which is square root of 5. So we can find the missing part of the triangle by doing 2 squared plus y squared is equal to the square root of 5 squared. So that'll be 4 plus y squared equals 5. Y squared will be equal to 1. And once again, y could equal plus or minus 1. Now in this case, because we are in quadrant 4, you are going down, so the y value will be negative 1. So now we know that sine of beta is negative 1 over the square root of 5, which can simplify to negative square roots of 5 over 5. Cosine of beta is 2 over the square root of 5, which is 2 square roots of 5 over 5. And tangent of beta is negative 1/2. Now that we know the three trig functions of alpha and beta, we will now use the sum and difference formula to calculate sine of alpha plus beta. So remember the formula for sine of alpha plus beta is sine of alpha cosine of beta plus cosine of alpha sine of beta. So we're going to plug in what we know for each of these. Sine of alpha is equal to 3/5. So that's right here. Sine of alpha is 3/5. We don't know what alpha is. We don't know what the angle is. We don't need to know what that is. We could find it, but we don't need it. We want to know what sine of alpha's ratio is. So that's 3/5 times cosine of beta, which is over here. That's 2 square roots of 5 over 5. Plus cosine of alpha, 4/5, times sine of beta, negative square roots of 5 over 5. And then we're just going to multiply these two together and add them. So if we multiply 3 times 2 square roots of 5, that's 6 square root of 5. 5 times 5 is 25. Plus 4 times negative square root of 5 is negative 4 square roots of 5 over 25. Those are like terms, so we can combine those to get 2 square root of 5 over 25. So sine of alpha plus beta is 2 square roots of 5 over 25. Now we'll look at B, cosine of alpha plus beta. Once again, using the formula for sum of cosine, we have cosine of alpha, cosine of beta, minus sine alpha, sine beta. So cosine of alpha, look at the first triangle, has a ratio of 4/5. Cosine of beta has a ratio of 2 square roots of 5 over 5, minus sine of alpha is the ratio of 3/5, and sine of beta, second triangle, is negative square root of 5 over 5. Once again, we can calculate by multiplying the numerator, so that's 8 square roots of 5, and then the denominators, which is 25, minus 3 times negative would be negative 3 square roots of 5 over 25, and so minus a negative, you're going to be adding those, so it would be 11 square root of 5 over 25. So cosine of alpha plus beta is 11 times the square root of 5 over 25. And then the last one we will be looking at will be tangent of alpha minus beta. So tangent of alpha minus beta, the formula for that is tangent of alpha minus tangent of beta divided by 1 plus tangent of alpha tangent of beta. So tangent of alpha is 3/4 minus tangent of beta on the second triangle is negative 1/2. So we'll be adding those. And then the denominator is 1 plus tangent of alpha, which is 3/4 again, and tangent of beta is negative 1/2. So we need to find a common denominator on top. That would be 3/4 plus 2/4. And then on bottom we have 1 minus, take 3/4 times negative 1/2 would be negative 3/8. So 1 minus 3/8. And then 3/4 plus 2/4 is 5/4. And then 1 minus 3/8 is 5/8. So now we can multiply by the reciprocal, and that would give us 5/4 times 8/5. The 5's cancel. 8 divided by 4 is 2. So tangent of alpha minus beta is equal to 2. So once again, on these problems, the given is all that stuff on the top right below example 1. So sine of alpha, where it's located, cosine of beta, and where it's located. Depending on which of the three that I ask you for, if I only ask for sine of alpha plus beta, then you don't need to find the tangent, okay? But tangent, you will need to find that. So it all depends on what is being asked as to what information that you need to find. But whether I'm asking sine or cosine, you do need sine of cosine of both angles to do that. But wait, there's more. We've got one more we're going to look at. We're going to verify the identity or establish the identity using sum and difference formulas. So on this one we have cosine of pi plus theta is equal to negative cosine of theta. We're going to use the sum formula for cosine, so it would be cosine of pi times cosine of theta minus sine of pi times sine of theta. Since we know that pi on the unit circle has an ordered pair of negative 1, 0, we can evaluate cosine of pi would be negative 1 times cosine of theta minus sine of pi is 0 times sine of theta, and this was supposed to be a theta here on this side, not pi, sorry about that. And negative 1 times cosine is negative cosine of theta minus 0 times sine of theta is just 0, so that's equal to negative cosine of theta. So once again, we are going to be continuing to establish or verify identities, but we now will be also including the sum and difference formula. So that is it for this day 2 of sum and difference formulas. Once again, write your summary down for this section. And with that, my daughter has added a little bit extra to this video for your amusement and pleasure.
Name the salmon. Oop. Thank you for watching. Could you guess this animal? It's an animal.
What animal is it?
It's the cat animal, a leopard.
A leopard. If you would like more lovely drawings from Evelyn, you can subscribe to my YouTube channel.